What if I told you that everything we understand about science might just be an illusion? Imagine a world where the fundamental principles we rely on, like gravity and quantum mechanics, are not what they seem. What if gravity is merely a clever disguise for something else? A cosmic deception that keeps us grounded in a false reality? Think about it. Every planet, every star held in orbit by is nothing more than an elaborate ruse. And then there's quantum mechanics, the bizarre science of the very small. It tells us particles exist in multiple states at once, only settling on one when observed. But what if this too is part of a grand illusion? What if the universe is like a vast stage, with particles as actors that only perform when we're watching? Let's not stop there. Consider the multiverse theory, an endless sea of parallel realities based on the choices we make. But could this too be a trick, a cosmic illusion to make us believe in infinite possibilities? Now think about black holes, these monstrous cosmic vacuums that supposedly swallow everything, even light. But what if they're not just devouring, but transforming? Recycling matter and energy in ways we can barely comprehend, hidden behind the curtain of the event horizon. And finally, entertain the possibility that our entire universe is a simulation, a complex program run by higher beings with us as mere characters in an elaborate digital drama. Glitches in this program could explain the unexplained, the UFOs, the inexplicable phenomena. Perhaps these are signs that we are living in a crafted reality, hints from our cosmic programmers. As we explore these thought-provoking scenarios, remember, science is a human endeavor. It evolves, changes, and adapts. Whether these ideas are mere fantasies or glimpses into deeper truth, they challenge us to question and think deeper. So what do you think? Is our universe a grand illusion? Or is it the genuine article? The mystery continues, and it's up to us to keep seeking answers. Keep pondering the mysteries of this grand illusion we call the universe. Let's explore some real-life examples of how illusions play tricks on our perceptions, both in everyday life and in the vast cosmos. First, let's talk about MP3 compression. While not directly cosmic, this technology relies on an auditory illusion. It discards inaudible sounds to shrink sound files without significantly affecting perceived quality. Your brain fills in the gaps, making it seem like no information was lost. It's a fascinating example of how our minds can be easily deceived. Next, consider futuristic light bulbs. Cognitive neuroscientists have discovered an illusion that allows a light bulb to flicker off for 13% of the time but appear as bright as if it were on continuously. By exploiting this illusion, energy-efficient light bulbs could save up to 20% on electricity bills. It's a simple trick that could have a big impact on our energy consumption. Now, let's venture into space with pareidolia in cosmic clouds. Pareidolia is the phenomenon where people see recognizable shapes in unrelated objects. In the cosmos, we often observe cloud formations that resemble familiar shapes such as animals or faces, even though they are random cosmic structures. For instance, an image from NASA's Chandra X-ray Observatory of PSR B 1550958, a spinning neutron star surrounded by a cloud of energetic particles, gained attention because many saw a hand-like structure in the X-ray emission. Similarly, other celestial formations may trigger our pattern recognition instincts, leading us to perceive shapes that aren't truly there. Another intriguing example is the sky blue cafe wall illusion. This optical illusion, created by artist Victoria Sky, features horizontal lines that appear slanted but are actually parallel. Squinting at the image or viewing it from the side reveals the truth. It's a compelling reminder of how easily our eyes can be fooled. Lastly, let's consider the Hermann grid optical illusion. While not directly cosmic, this optical illusion demonstrates how our visual system can deceive us. When viewing a grid of black squares with white intersections, we perceive grey dots at the center of each intersection. However, these dots seem to shift between white and grey as we focus on different parts of the grid. It's a reminder that our perception is influenced by context and neural processing. These examples show that illusions are not just confined to the realm of the cosmic, but are also a part of our everyday experiences. They challenge our understanding and remind us that what we perceive might not always be the complete truth. So keep questioning and stay curious, because the universe is full of mysteries waiting to be uncovered. Stay tuned for more mind-bending insights into the nature of our universe. Keep pondering the mysteries of this grand illusion we call life. As we continue our journey through the enigmatic world of illusions, let's delve into the realm of time and motion. concepts that are far more deceptive than they first appear. First, let's explore the idea of theoretical physicist Carlo Rovelli argues that our naive perception of time's flow doesn't correspond to the deeper reality of the universe. In his book, The Order of Time, Rovelli dismantles common-sense ideas about time. For instance, Einstein showed us that time is just a fourth dimension, and there's nothing inherently special about the present moment, or now. Even the concepts of past and future aren't always well defined. The malleability of space and time means that events occurring far apart might even happen in different orders when viewed by different observers. Rovelli posits that reality is a complex network of events onto which we project sequences of past, present, and future. The whole universe obeys the laws of quantum mechanics and thermodynamics, out of which time emerges. Think of the block universe, supported by Einstein's theory of relativity, as a four-dimensional space-time structure where time is akin to space. In this view, every event has its own existence, and the past, present, and future coexist as fixed elements within this block. It challenges our intuitive linear perception of time. Next, let's consider that the Milky Way and the entire universe exhibit uneven time. We observe faster time areas in spiral galaxies such as their arms and as cosmic web filaments. However, absolute time, running at the same pace everywhere and always, exists only as a local approximation. Finally, let's delve into the concept inspired quantum gravity. Rovelli introduces the idea that some equations in quantum gravity can be written without any reference to time. The apparent existence of time, both in our perceptions and in physical descriptions, arises not from knowledge but from ignorance. The direction forward in time corresponds to the increase in entropy, a measure of disorder where we gain information. Entropy plays a crucial role in our perception of time. These mind-bending ideas challenge our understanding of reality and remind us that our perceptions of time and motion are not as straightforward as they seem. They invite us to question the very fabric of our existence and explore the deeper mysteries of the universe. Stay curious, because the universe is full of wonders waiting to be uncovered. Now, let's take a closer look at the block universe theory, a concept that radically challenges our intuitive understanding of time. What is the block universe? According to the block universe theory, the universe is like a giant four-dimensional block that contains everything that has ever happened and will happen at any time and any place. In this view, the past, present, and future all exist simultaneously and are equally real within this cosmic block. Visualizing the block universe. Imagine the block universe as a three-dimensional rectangular cuboid. Two of its dimensions represent two of the universe's three spatial dimensions, height and width. The third spatial dimension, length, is replaced by time. Thus, the cuboid extends from the Big Bang at one end to the very last moment of the universe at the other end. Every event that ever occurs, whether it's your birth, your death, or the moment you're watching this video, exists somewhere within this block. Time doesn't pass in the block universe. Our everyday experience suggests that time flows or passes. We perceive a changing present, and yesterday seems different from today. However, in the block universe model, time doesn't flow. There is no specific fixed present moment, and the concepts of past and future are relative. Think of it like the concept of here. When you say, "I am here," your here is different from mine. Similarly, talk about the present or now works similarly. It depends on where you happen to be in space-time. Implications and philosophical questions. The block universe theory raises profound questions. Is our perception of time merely an illusion? If all moments exist simultaneously, what does it mean for free will and causality? How do we reconcile this view with our everyday experience of time passing? Some physicists and philosophers argue that the block universe aligns with the implications of Einstein's theory of relativity and the idea that time is just another dimension. As we ponder these questions, we are reminded that our understanding of reality is constantly evolving. The block universe invites us to see time not as a flowing river, but as a vast, unchanging landscape. It challenges us to rethink our place in the cosmos and to consider the possibility that every moment is eternal.